Hello and welcome. Today we're going to continue our discussion on quadratics by talking about the two different forms of the equations that you can have. We can have either standard form or vertex form, and we're going to go into depth more in this lesson today. First, let's recall graphing the parabola. What we are going to do is create a chart. Our vertex, I will just tell you, is going to be at the point 0, 0. So I want two numbers smaller, -1 and -2, and two numbers larger, 1 and +2. Plugging these in, y when x is -2 is going to be a +4. So I have the point -2, +4. Plugging in a -1, when I square -1, I get a y value of +1. When I plug in a +1, I also get a +1. And when I plug in a +2, I again get that +4. We've talked about from the vertex, which should be that middle point on your graph, if you go one unit down and then another unit down, and one unit up and another unit up, if you follow that pattern, then the first and the last y values will be the same, as will the second and the fourth y values. So from here, I'm going to go ahead and plot these points to sketch my graph. I have the point -2, +4, 1, 2, 3, 4. I have the point -1, 1, 0, 0, 1, 1, and 2, 4. Graphing your parabola, we have this U shape. Remember that your graph is symmetrical on the left and on the right. The pattern in your coordinates, you may or may not have identified this, is that if you start at the vertex, you're going to go left 1, up 1, left 2, up 4. So remember, these are the points that I had on my graph. I'm going to go ahead and start at my vertex. If I go left 1, up 1, I land on the coordinate -1, +1, which is on my graph. From the vertex, I'm going to go left 2, up 4. And again, I land on the coordinate on my graph. On the right, I may repeat this, except towards the right instead of towards the left. I can go right 1, up 1, and right 2, up 4. So as soon as you find your vertex, we can simply follow this pattern to find the rest of our points. However, the pattern will change if the leading coefficient is not 1. Remember this leading coefficient? That's the coefficient in front of x squared, or the number in front of x squared. In this case, I have a 1 in front of my x squared, so I may use this pattern. Later, we'll discuss how the pattern will change if you have a different number in front. So let's go ahead and graph the parabola. First thing we're going to do is identify the vertex, and then we are going to use a pattern, if possible, to find the remaining points. And when I say if possible, I mean if the leading coefficient is 1. Again, later we'll talk about what to do when the leading coefficient is not 1. So to find your vertex, I start with x equals -b/2a. b in this case is a -2. b is +2. On the top of my fraction, I make that a -2 over 2 times a, which is +1. So I have -2 over +2, which reduces down to a -1. Now to find the vertex, I need to take the x value and plug it in. So the y value when x is -1 is -1 squared plus 2 times -1. -1 squared is 1, minus 2 gives us a -1. So our vertex is the point where x is -1 and so is y. So I'm going to go ahead and put this value in the middle of my chart. I have -1 for x, -1 for y. I need two x values that are smaller, so that will be -2 and -3. And two that are larger, those will be 0 and 1. From here, you may complete your chart if you'd like, or you may use the pattern that we just talked about and not proceed with the chart. You have the option. I'm going to go ahead and proceed with the pattern. We know our vertex is the point -1, -1. So I'm going to plot that point on the graph, -1, -1. Since the leading coefficient here is a +1, or when you look up here to your graph, I have a +1 as the very first number. I may follow my pattern. I go left 1 and up 1. So from my vertex, I go left 1, up 1. I then go left 2, up 4 from my vertex. So starting here, I go left 2, up 1, 2, 3, 4. And on the right, I repeat that pattern. Right 1, up 1 from my vertex, and right 2, up 4 from my vertex. Here's my vertex, right 2, up 1, 2, 3, 4. Again, you'll notice that the graph is symmetrical. These y values are the same, and so are these y values. So your parabola should look like this when you are done. Whether you use the chart or the pattern, your parabola should look the same. Go ahead and pause the video and try this next one on your own. Find your vertex, and then use the pattern to find the rest of the points on your graph. Your vertex should be at the point -2, -5. From there, left 1, up 1, left 2, up 4, right 1, up 1, right 2, up 4, giving you this graph of a parabola. What I'd like to do on this slide is have you compare each of the following graphs to their equations. I am going to quickly sketch each of the graphs, and we're going to see how those pictures relate to the equations from which they come. This first graph has a vertex at the point 0, 0. From there, I follow my pattern, left 1, up 1, left 2, up 4. And on the right, same thing. Sketching my graph, I have a vertex centered at the origin. On the right, the vertex is at the point 0, -4. And from here, I follow my pattern, left 1, up 1, left 2, up 4, right 1, up 1, and from the vertex, right 2, up 4. Your graph should look like this. Very similar to the last one, except now it's a little bit below the x-axis. Here your vertex is at 0, 3, and we follow our pattern, left 1, up 1, from the vertex, left 2, up 4, right 1, up 1, from the vertex, right 2, up 4. Connecting your dots, again, we have a very similar graph, except it's been shifted upwards 3 units. Last, I have a vertex at the point 0, 6, and I follow my pattern, left 1, up 1, left 2, up 4, right 1, up 1, right 2, up 4. Connecting our dots, this is our parabola, and it has been shifted up 6. If you notice, this graph was centered at the origin. This graph was shifted down 4 units. This graph was shifted up 3 units. And this graph was shifted up 6 units. So from this original, we just moved it up or down. You might notice that that shift was related to the number that we added on to the end of each equation. So our conclusion? The constant term, or the number that's just added on to the end, shifts the graph vertically that number of units. Next slide. Our vertex is again for this first graph, 0, 0. I go left 1, up 1, left 2, up 4. Right 1, up 1, right 2, up 4 from the vertex, giving you basically your home base graph. This is just your standard parabola. Here to the right, my vertex is going to be at +4 for x, 0 for y, and I follow my pattern from there. So your graph will look something like this. Very similar to the last one, except it's been shifted right 4 units. My next graph has a vertex at -3, 0, and I follow my pattern to find the remaining points. Connecting the dots, I see that it's very similar to my original, except it's been shifted to the left 3. And last, again, very similar, except I am shifting my graph to the left 6 units. So you might notice, just like I shifted my graph vertically on the last slide, I am now shifting it horizontally on this slide. Here I shifted it to the right 4 units. Here I shifted it to the left 3 units. And here I shifted it to the left 6 units. You might be seeing that those numbers are coming from the numbers inside my parentheses. Those numbers are stuck with the x. I am shifting the opposite number in the horizontal direction. So I went positive 4, negative 3, and negative 6. So our conclusion, the constant term that's added only to the x shifts the graph horizontally that number of units. However, we make those units opposite. Standard form versus vertex form. Standard form is in the form ax squared plus bx plus c. We use this equation where x equals negative b over 2a to help find our vertex. Once we find x, we plug it in to obtain y. Vertex form follows this equation. To find the vertex of your parabola, the x value is the opposite of whatever number is in parentheses. The y value is the number added on to the end. We're going to go ahead and find the vertex for each of the following graphs. First, in standard form, I find the x value by using the formula where x is negative b over 2 times a. b is a positive 4, so I have negative 4 over 2 times a, which is positive 2. That's negative 4 over 4, which reduces to negative 1. I now plug that in to find the y value. F of negative 1 is 2 times negative 1 squared plus 4 times negative 1 minus 1. Simplifying, I have 2 times 1 minus 4 minus 1, and you should end up with a negative 3. So your vertex is the point where x is negative 1 and y is negative 3. Now from vertex form, we have a much more quick way to find our vertex. We look at the number that's being added to the x. Here it's a positive 1. Well, your vertex is going to have the opposite x value, so a negative 1. Your y value is simply the number that's added onto the end, which is a positive 4. So your vertex is simply negative 1, 4. Go ahead and pause the video and try the next 4 on your own. For the first, you should have an x value of 2, y value of 3, giving you a vertex of 3, 2. Second, the opposite of my negative 4 gives me an x value of positive 4, and my negative 1 added onto the end should have given me a negative 1 for my y value. Last, you should have 3, 3, and 3, negative 4. Now we're going to go ahead and move on to graphing. Step 1, let's identify the vertex. For this first equation, your vertex has an x value that is opposite the number in parentheses. So my vertex has an x value of positive 4 and a y value of negative 3. I plot that point, 4, negative 3. Step 2, I determine the appropriate pattern. Since there is no number in front, I assume it's a 1, which tells me I can follow my pattern left 1, up 1, left 2, up 4, and the same on the right, left 1, up 1, left 2, up 4, right 1, up 1, right 2, up 4, and connect your dots to graph. On the right, we are going to do something very similar, except it's a little bit more work to find your vertex. We need to find our vertex using x equals negative b, which would be negative 8 over 2 times a, which is 1. This all simplifies to negative 4. We then plug that in to find the y value of our vertex, which should be a positive 2. So your vertex is negative 4, 2, and we then follow our pattern to find the remaining points, left 1, up 1, left 2, up 4. Since your leading coefficient is 1, we can in fact use this shortcut of a pattern. Go ahead and try this next and last slide on your own, and have a wonderful day.